we're going to talk about parabolas and the characteristics of parabolas. Graphing quadratic functions. First of all, when we're talking about graph of a quadratic function, we call it a parabola. Parabolas are shaped either like balls or like inverted balls. Consider a quadratic equation of the form y equals to ax squared plus bx plus c. If a, or the leading coefficient, is positive, then you have a parabola that opens upward like a ball. And if a is negative, then the parabola opens downward like an inverted ball. Whether the parabola opens upward or downward depends on the coefficient a that we call the leading coefficient. Ax squared is the leading term. Why is that? Because the degree of x is the highest. When we're talking about graph of quadratic functions, we're basically talking about parabolas. F of x is equal to ax squared plus bx plus c, and a is not 0. Why? Because if a becomes 0, you get a linear function. We're not working with linear function. We are past over the linear function. We're just talking about quadratic functions. What is the vertex? When you're talking about a vertex, you're talking about the maximum or minimum value of your function. The vertex also has another name that we call it the turning point of the parabola, is the lowest point on the graph when it opens upward, and it is the highest point on the graph when it opens downward. So vertex or turning point. True or false? The vertex of a parabola is also called a turning point. We just learned that this statement is a true statement. So when you're talking about the graph of parabolas, we can also rewrite the quadratic function of the form a parenthesis x minus h to the second power plus k. You can convert this into ax squared plus bx plus c, or we can keep it as it is. Quadratic functions in the form f of x equals to a parenthesis x minus h squared plus k. The graph of f of x, a x minus h to power 2 plus k, and please note that a cannot be 0, is a parabola whose vertex is actually the point h, comma, k. So if your function, quadratic function, is given in this format, then you can easily identify the vertex, the highest point, or the lowest point as h and k. The parabola is symmetric with respect to the line x equals to h. Again, as you remember, if a is positive, the parabola opens up, and if a is negative, the parabola opens down. So when it comes to graphing a quadratic function with equation of this form, f of x equals to a parenthesis x minus h to the second power plus k, first of all, you need to determine if the parabola opens up or down. That depends on the coefficient a. If a is a positive number like 2, 1, a half, then the graph opens up like this. And if a is negative, like -1, -3, -4, and so on, then the parabola opens down. Make sure to identify the vertex. Again, the vertex is either the highest point or it is the lowest point, h, comma, k. Next, as you remember, you need to find the x-intercept, point of intersection with x-axis, and you can also find y-intercept. These points help you to graph a quadratic function graph that we call a parabola. As we mentioned, you need to find the y-intercept and then plot the intercepts, the vertex, and any additional point that you need to understand and analyze the behavior of your parabola. Very good. So the very first example, graph the function f of x equals to -2 parenthesis x plus 4 to the second power minus 8. Well, compare this function with the general form of a quadratic function. A quadratic function we introduced is a parenthesis x minus h to the second power plus k. Well, this example says you have a -2 multiplied by the parenthesis x plus 4 to the second power minus 8. So let's identify this. A is a negative number. So it means that the graph opens downward. X plus 4 in the formula, we need to see a minus sign. So what's the meaning of that? It means that your h was originally a negative number. H is -4. And finally, k is -8. Don't let these minus and plus sign confuse you. When you see x plus 4, it needs to have a minus sign in between x and that number. So this number was originally a negative number. When it comes to plus k, k is also a negative number. So since a is -2, it's a negative number, the graph opens downward. To find the vertex, we identify h and k. By formula, the vertex is point -4 and -8. Let's go back to previous slide. A parenthesis x minus h to the second power plus k. A is -2, h is -4, and k is -8. And we have the vertex h, comma, k. Those two numbers are not necessarily positive. You might end up with negative numbers like this scenario, this case here. So we have A, which is -2. We have H and K, which is the vertex. And we can find x-intercept. To find x-intercept, we are finding the points of intersection with horizontal line where y is 0. So since y is equal to 0, you're going to set your function equal to 0. So you end up with -2 parenthesis x plus 4 to the second power minus 8. Well, what you can do, you can bring 8, -8 to one side, and or you can bring the other term to the other side. You end up with 2 times x plus 4 to the second equals to -8. What are you going to do next? You're going to get rid of this coefficient here. So divide both sides by 2. X plus 4 to the second power is equal to -4. So what's the meaning of that? X plus 4 becomes plus minus square root of -4. If you know about complex number, this is actually a complex value. Square root of -4 is 2i. We're going to talk about this more. So it seems like the points of intersection with x-axis are imaginary numbers. So what's the meaning of that? It means that the graph doesn't hit x-axis at all. We can find y-intercept as well. To find y-intercept, just substitute 0 for your x and find the y value. Y is -2 parenthesis 0 plus 4 to the second minus 8, or -2 times 4 squared minus 8, or -2, 4 to the second power is 16, -2 times 16 minus 8, which is -4. 40. So this is your y-intercept. What's the graph look like? This is the graph of your function. It opens downward. There is no intersection with x-axis. It's below x-axis. That's why you got imaginary numbers. This is the vertex, the highest point at -4. The highest value of your function is -8. Y-intercept is -40, and there is no x-intercept. Why? Because you found imaginary numbers.